All right, so how to experiment well, lesson 4.6. First, we better get a random assignment of the treatments, so the treatments are assigned to experimental units, or experimental units are assigned to treatments using a chance process. So we've seen the slips of paper, we've seen the random number generator. Those are the two most basic ways to do it. And then the other vocab words today, replication, is the idea that we should use enough subjects to create roughly equivalent groups. That's going to be our hard part when we do our golf experiment. We don't have very many people in this class, especially when the seniors are gone. So it's going to be hard to make it as fair as we could. Replication would be the idea of we need more people so we could randomly assign them and kind of get the fairness involved with that situation. So sources of variability, like how things vary, is one reason to keep other variables the same is to prevent confounding. Confounding was our vocab word from last time. Those were those other things that could be a factor of it. Like they were doing the caffeine experiment with the cola, and it was like the confounding variables were the amount of sugar in the soda, like the things that just weren't accounted for. So if you could randomly generate things, the groups, and make them large, confounding becomes less and less likely because it all gets taken care of. The second reason is to reduce the variability is the response variable, making it easy to determine if one treatment is more effective than the other. And then here's the three big rules to make a well-designed experiment. Control. If you have some control, like having a control group, it involves making the experiment as similar as possible for experimental units in each treatment condition. So if you could have some control. If you randomize things, so randomization refers to the practice of using chance or experimental. So we randomly select the treatments. And replication, that's a fancy word for make it big groups, so the more experimental units in each treatment condition, the lower the variability. So the bigger the groups, usually the less things vary. So replication. So here was that story about the cola experiment. Remember, he was trying to eliminate many sources of confounding by comparing two groups. One got cola with caffeine, the other got cola with no caffeine. Comparison alone isn't enough to produce the results that he wanted. Many other variables affect the pulse rates besides caffeine. We talked about them. The caffeine tolerance, you guys even mentioned that about me. It's like, hey, Fonnie, you can handle a lot of caffeine because you drink a lot of caffeine. So how one tolerates it, how heavy a person is by their weight, the recent caffeine consumption. We talked about maybe you had a Monster for breakfast, it's like, hey, that makes things. The characteristics of the subjects. Then there's sugar in there, the amount of soda that they drank, the temperature that it is. All of these crazy things are confounding variables. And if you make the groups large enough, then those confounding variables become less and less important because you would evenly distribute the amount of people that had Monsters for breakfast or could handle caffeine like a champion kind of stuff. The bigger the groups, the less variability will end up happening. So let's dive into the problems. I kind of printed it all out for us, and we just fill in the blanks. It's still about randomizing stuff. We just got to think this through a little bit. In Mr. Lucko's class, 20 students volunteered to participate in the caffeine experiment. Describe how you could randomly assign 10 students with slips of paper. So talk to me, guys. I know it's very close to the end of the semester. How many total people are in this experiment? 20. Here's what they're going to do. They're going to make some slips, say letter A and letter B, because they're going to split them into two groups. So if there was 20 students and there was two groups, how many people would be in each group? There's 20 students. We're going to do two groups. How many people would be in each group? 10. So that's why we don't do it on all 20 slips of paper. On 10 slips of paper, we're going to write A, and on the remaining 10 slips of paper, we're going to write B. So you're splitting them into two groups. Obviously, the pieces of paper are the same size. Then what we're going to do is shuffle the pieces of paper. Sometimes you put them in a hat. Sometimes you put them in whatever. You shake them up. You shuffle them up. And then you just come up and grab them. Everybody that gets an A will get the caffeine, and everybody that gets a B will have, no caffeine. So that's what the two groups were. You kind of assign that ahead of time. If you get an A, you get the cola with caffeine, and if you get a B, you get the cola without caffeine. That's how to do slips of paper. Slips of paper works good for small groups, you know, it's just like, all right, we can handle that. Random number generator, even easier to do. So on the random number generator, how many total people were there again? 20. So what do you want your random number generator to go to? 1 to 10 or 1 to 20? 1 to 20. 1 to 20, baby. And then generate, like, we're only going to do 10 different integers from 1 to 20. So if every person has a number, if I numbered you all out and I want to select 10 of you, it would just be the first 10 that you do in that case. The remaining 10 students would get the cola without the caffeine. Cool? So let's try that again. Random assignment should distribute the students who have a caffeine tolerance equally. I kind of talked about that. Like when you randomize it, that would just put the people that can handle caffeine, like it gives them a fair chance to be in each group. So, all right. Miss Cherney's class, 30 students volunteered to participate in the experiment to determine if chewing mint gum during a test will increase their score on that test. So let's say we took our big quiz next time. What if I had half of you chew the mint gum and half of you not allowed to chew anything? We'd want to see, like, hey, did chewing the mint gum make you do better? Well, what we'd have to do is just, like, split us up randomly. So there's 30 kids in that class. So on the slips of paper, when you do A and B, we got to cut her in half, right? We got to cut her in half. So how many slips of A? 15, and then 15 slips of B. What do you got to do to those slips of paper? Guess what goes in this blank? You're supposed to do something to the slips of paper and then hand out. We're going to shuffle them. Shuffle. Shuffle. See if you can do part B with your neighbor. How would you do it with a random number generator? Let's see what you got. Number the students 1 to what? 1 to, the choices are basically 15 or 30. What would you number the students to? 1 to 30, because there's all 30 of them. Then randomly generate 15 blank integers. So if you use a random number generator, 1 to 30, it is possible that sometimes it will generate the same number over again. So we need to say that they have to be different integers. Different integers. So like if I was to do the generator and it's like, okay, person 3, person 5, and then person 3 shows up again, I just got to skip over that and just like keep getting until I get 15 different integers from 1 to 15. What? Then randomly generate 15 is from 1 to 30 is what it should be. The students with these labels will chew mint gum during the test. The remaining 15 students will not chew gum. How do you feel about setting that up, man? That's a lot of questions on homework today and the quiz next time about how would you do it on slips of paper, how would you do it with a random number generator. So, sweet. Do you watch TV, or excuse me, does watching TV/movies make you snack? Just curious. What do you think, yes or no? Like if you were to watch a movie or to watch TV, more or less likely to snack? According to a recent study, the answer is yes. 94 college students were randomly assigned to one of 3 treatments. So check out these 3 treatments. Watching 20 minutes of a Hollywood action movie, that's treatment 1. Watching the same 20-minute excerpt of the movie, but they had no sound. And then the third treatment was watching 20 minutes of an interview program. Real quick, help me guys, I know we're tired. In those 3 treatments, something was kept the same. Something was kept the same. Discuss that with your neighbor. What was kept the same? I heard it. What was kept the same? The time. The 20 minutes, right? 20 minutes was kept the same, so that's cool. Okay, while watching, participants were given snacks, M&Ms, cookies, carrots, and grapes, and allowed to eat as much as they wanted. Subjects who watched the movie excerpt sound ate 65% more calories than subjects who watched the interview show. Participants who watched the silent version of the movie watched 46% more calories than those who watched the interview show. Explain the purpose of random assignment in this experiment. Random assignment was to help avoid that magic C word that says we've got to like get rid of all the weird stuff. That is confounding. Confounding was to avoid confounding. That gets rid of the weird variables that you don't take into account by creating 3 groups of college students that were roughly equivalent at the beginning of the experiment. So when you use random stuff, you'll get roughly equivalent things. Right? So the random assignment is to help avoid confounding by creating 3 groups of college students that were roughly equivalent. So in the TV and snacks example, They said people consume more calories when watching TV shows that they're more entertaining. Identify one variable the researchers kept the same. We said it. What was the one variable that they kept the same? The amount of time watching TV. That was 20 minutes. If one of the treatment groups was allowed to watch TV for a longer period of time, you wouldn't know like how the calories worked, because it's like, hey, if they got to watch for an hour, you know, and these people only watch for 20 minutes, then the measuring the amount of calories they ate is worthless, you know, because it's like, whoa, dude, you know, so you got to keep the time the same. This would be much more variable. Things would vary. If the researchers let subjects watch TV for as little as long as they wanted, the number of calories consumed would be much more variable than it would otherwise, making it harder to tell if the type of program makes a difference. Cool. One last thing, and then we are done. Random assignment works best when there are many subjects in the experiment. I've said that many times today. If only 6 people participated in the TV watching experiment, the 3 groups are likely to be quite different, even if they were randomly assigned. For example, if 4 of the 6 volunteers are female, then it's like a guarantee that one of those treatment groups would be 100% female. That's not good, you know. It's like you got to have more people. So in the actual study, there was 57 girls and 37 boys. With this many subjects, it's almost impossible that one of them will all end up the same gender. So this is called replication, which we already defined on the front page. The replication is the idea we should use enough subjects to create roughly equivalent groups. Replication is all about make your sample size of people big, you know, make it big. The bigger, the better, because then it will get rid of the compounding variables. So last one, baby. Researchers in Canada performed an experiment with university students to examine the effects of multitasking on student learning. This is kind of a cool one for today's day and age. 40 people in the study were asked to attend a lecture and take notes with their laptops. So half of the participants were randomly assigned to complete other online tasks not relating to the lecture during that time. So they multitasked. These tasks were meant to imitate typical student web browsing during classes. The remaining simply took notes with their laptops. So half of them multitasked, half of them took the notes. At the end of the lecture, all participants took a comprehensive test to measure how much they learned. Here's what happened. The students who were assigned to multitask did 11% worse, significantly worse than the students who were not assigned to multitask. Instead of writing it down, if you would just out loud, how, like explain to your neighbor, how could they have randomly assigned the 2 groups of 20 people? Please tell someone near. You'd use a random number generator, go 1 to 40, number every person in class, and then the first 20 people that get selected are in one of the groups. So explain the purpose of random assignment in the experiment. To create what kind of groups at the beginning? What do you want your groups to be? What do you want your groups to be? What's roughly what? Roughly equivalent. Roughly equivalent. To randomly make that groups is to get them roughly equivalent. What was one variable that they kept the same in all subjects in this one? What was kept the same? There's actually a couple things, but what's one thing you noticed? So it was said that one of the things that was the same was they took the same test at the end. Would you agree with that? The other one is the time of the lecture. The time of the lecture. Like the lecture was the same length. I think they were all in the same room also, you know. So like the time of the lecture or the test. I think both of those are like possible good answers. Cool.